Hey everybody, hope you all are doing good. This is Daniel Jones's PAD 730 Module 4.4 final assignment. The purpose of this presentation is to demonstrate how data analytics is currently being used to improve government operations and decision making. The first thing that needs to be clarified is what exactly is data analytics? According to Charles et al., data analytics is a broad field involving data tools and processes that include both computational and management steps to make data-driven informed decisions. Data analytics is useful because it allows for meaning to be extracted from raw data. This is usually accomplished by using specialized software and computer systems that enable data to be organized and transformed into useful models, which allows for patterns to be identified and conclusions to be drawn. Data analytics can improve public administration and policymaking in several ways. For one, it can help organizations improve decision making. It is hard to argue with the fact that more data can improve decision making. With the ability to analyze and model vast amounts of data, organizations have more concrete evidence to base critical decisions on. Trends and conclusions that are drawn from large amounts of data help policymakers make the best informed policy decisions, which leads to better outcomes overall. Data analytics also improves the transparency and accountability of decisions. When policymakers use data-driven conclusions to construct policies, the rationale behind policy decisions can be clearly demonstrated. Such transparency can build trust among citizens of governments because they can see why decisions are made. Data analytics can also be used to hold policymakers more accountable for their actions, because data can be analyzed to determine the effectiveness of policies. Data analytics can also be used for proactive problem solving. The use of data analytics can assist governments to identify potential problem areas before they accelerate into major issues. This can be accomplished by analyzing historical data and reviewing for trends. By doing this, policymakers can proactively work on solutions to anticipated challenges before they develop into major crises. This is particularly important with the more complex issues that are present in today's society. Public policy focus, traffic congestion. There are many underlying causes of traffic congestion. The three primary causes are traffic flow patterns, capacity of roads, and driver patterns. A combination of these can lead to even worse cases of congestion and also tends to be worse at intersections and travel junctions. This is a particularly important policy area as many municipalities see population growth. One traveling through many urban areas of North Carolina can argue that their trip was smooth during rush hour. However, what seems as an inconvenience right now will likely become a crippling problem in the future unless politicians and policymakers have the forethought to improve traffic conditions. The following slides will outline how data analytics can improve policy-related traffic congestion within a municipality and give some additional details about its use. Practical applications. Traffic congestion is a very troubling issue for many reasons. Traffic congestion leads to deaths and accidents. It causes excess fuel consumption and is therefore bad for the environment and is overall just bad for society as a whole. To help alleviate the traffic congestion and the problems related to it, the concept of intelligent transportation systems, ITS, has been developed to improve this issue. ITS uses a combination of processes to improve traffic. These include sensor technology, data collection, and transfer and control technologies. A big way that ITS improves traffic congestion is by first collecting constant real-time traffic data. This data can then be transmitted to central data centers that will then disseminate data to traffic signal systems so that traffic would back up as little as possible. Central data centers have been used to distribute real-time traffic conditions to members of local communities, which allow for route optimization as traffic conditions rapidly change. Singapore is a real-life example where ITS has been implemented in recent years. Within the country's larger cities, the average speed of traffic has been around 27 kilometers per hour. This can be compared to other big cities such as London with an average speed of 16 kilometers per hour, or Tokyo with an average speed of just 11 kilometers per hour. Cities within Singapore have accomplished this by equipping taxis with GPSs that constantly monitor traffic conditions, and by also using data collection centers that provide members of the community with real-time traffic info. Additional practical applications. As the alternative to dealing with continuing traffic congestion issues, policymakers can also use data analytics to proactively improve or prevent traffic congestion in the future. One method of using data analytics to proactively plan for traffic congestion issues is by developing predictive models. Such models can use historic data inputs, such as accident records, changes in road conditions, and traffic flow history to predict which sections of roads could benefit from traffic optimization methods, like road improvements. Additional data points, such as geographic information, and the timing of important events adds validity and accuracy to predictions and conclusions drawn from such models. Additionally, artificial intelligence can be combined into such predictive models to increase efficiency of predictions. Transformer-based time series methods have been used for traffic flow predictions. Such methods have been used successfully in analyzing extensive time series data like those used in extensive traffic pattern and history research projects. There are some challenges for organizations to think about when considering incorporating a data analytics program. Some of the major items to consider consist of the large volume of data to be collected. This proves to be one of the greatest challenges that an organization faces within the constantly changing field of data analytics. The amount of new data that is created each day makes it difficult for organizations with traditional data infrastructures to keep up. This necessitates organizations to invest in new cutting-edge technologies, such as cloud-based systems and data analytics platforms that provide real-time analytics. Another challenge in implementing a data analytics program is the work of sifting through the vast amounts of data gathered in order to glean relevant data. The need for real-time data is becoming increasingly important for many organizations that use data analytics for purposes-driven decision-making. This makes manual processes to analyze data impossible. To combat this issue, organizations are turning to data systems that gather data, organize it, and then notify users of new trends automatically and in real time. The validation of data continues to be a challenging area within data analytics. To help ensure data is valid and accurate, many organizations are turning to open source platforms and scripting methods. This involves using corporate software and programs or coding. Finally, an important challenge area to consider is the need for data visualizations. It is a best practice that data be presented in visual forms like charts and graphs. Such representations can be difficult and time-consuming to develop, however, if the process is too manual. To help in this process, organizations should invest in data visualization tools and technology which allow for ever-changing data to be incorporated quickly and easily. When an organization is thinking about implementing a new data analytics program, it must consider that there are both pros and cons. A few of the major pros are improves public services. Organizations can use data analytics to optimize resource allocation and improve citizen engagement. It improves decision-making capabilities. Data analytics can help policymakers make better decisions by harnessing the power of big data. Policymakers can use findings related to trends and patterns to be better informed in implementing policy decisions. There are also some cons related to implementing a data analytics program. Most of the cons related to the actual implementation stage, however, so that should be considered when thinking about an ongoing data analytics project. Some of the cons are data security and privacy. Collecting and analyzing large amounts of data carries the extra risk for privacy breaches and risk to security vulnerabilities. For this reason, organizations must be extra vigilant to safeguard data by employing multiple methods and strategies. The cost of implementing data analytics. The cost of implementing a data analytics program can be significant due to potential high cost of infrastructure, software, and additional staff. There may also be additional ongoing costs for such items as data storage, maintenance, and processing. Such costs may lead to data analytics programs not being feasible for some smaller organizations. One final con that must be considered is the fact that data analytics programs algorithms could display bias and discrimination based on factors such as race and gender. This is even true after the removal of the human factor within algorithms because of the fact that humans create the instructions for the algorithms. Here are some real-life examples of how data analytics can improve outcomes for policymakers and the communities they work for. Purdue University adopted data analytics in the field's infancy. The university developed an early intervention system called Signal back in 2007. The system used predictive modeling based on student data points to accurately forecast which students were at the highest risk of dropping out. Based on this data analytics system, the college could intervene and help students with any issues that they may be having, which would prompt them to drop out. One study found that students who were using this program were 21% less likely to drop out. The Federal Housing Authority is using data analytics to help forecast default rates, repayment rates, and claim rates. The FHA has the only subprime mortgage insurance fund that didn't need a bailout during the housing bubble crisis of 2008, and a part of this was their use of data analytics, even back then. The FHA also uses data analytics to model different scenarios to determine premium levels and ensure positive cash flow. Finally, the City of Ottawa used predictive data analytics to improve emergency response. They did this by using geographic programs to map the potential damage that each additional centimeter of rainwater could cause and predict which areas would be the most affected. Conclusion. To conclude this presentation, data analytics is becoming an increasingly important tool for government organizations to greatly improve decision making. A primary benefit of its use is that it helps policymakers analyze huge amounts of data for trends and patterns, which is very useful in making important decisions. In this presentation, the example policy of traffic congestion was discussed, and the innovative ways data analytics can be used to improve it was detailed. In actuality, however, the use of data analytics are only limited to the imagination of policymakers. Some of the challenging of implementing a data analytics program was outlined, and also ways to help work through these challenges. A pros and cons list of implementing a data analytics program was also detailed. Finally, to show how impactful a successful data analytics program can be, real-life examples of government data analytics programs were highlighted. From a practical standpoint, and to give recommendations based on the research within this presentation, data analytics programs is a great tool for organizations who have the means and resources to gain an advantage based on large amounts of data they already possess and what the data can tell them. Furthermore, to build trust within their communities, data analytics can help policymakers become more transparent on why decisions were made. This is because decisions will be backed by large amounts of data, which can be demonstrated to the community. References.